Hello guys, this is Sina. Welcome to the Machine Learning Mindset. In this tutorial, I'm going to talk about TensorFlow tensors. So in general, tensors, as I wrote for you here, are multidimensional arrays that are using TensorFlow for lots of different, well, basically every operation that TensorFlow does it. So the rank is a sort of definition which is in general the number of dimensions that a vector has, or one variable that we define by TensorFlow. So let's just go ahead and get started. Here I am going to import TensorFlow as TF and numpy as NP as usual. So we wait for Google Collaborate to get connected. Alright, we have imported the libraries, and here I'm going to define a constant tensor which has only one element. Let me just show you what the constant tensor is. You can always refer to TensorFlow official repositories. So the constant tensor, as code by TensorFlow, it creates a constant tensor from a tensor-like object, and that object here for us is just a simple 0. And you can refer to some other examples, more comprehensive examples provided by TensorFlow. Okay, so now let's just go ahead, define this tensor, print the tensor rank with tf.rank command and the tensor itself. Let's just go ahead and run it. Right, here's our tensor. As you can see, it's just a 0, and the tensor showing the full tensor is like tf tensor 0. There is no shape for that because it's just a mere 0, and type is int 32. All right, now let's go ahead and define another sort of tensor with kind of different actually numbers. It's like a vector instead of one number, and we show the tensor and tensor rank. The numpy.numpy method can be used to go from a tensor to the numpy, which is a regular commonly used type of data that we're using. So because not all operations by tensors can be done on Python, but when we return it to numpy, everything is written based on numpy. We're going back from tf tensor to numpy as I just wrote it for you here. Let's just run it. You do see the output here because I just ran it previously. Now we just want to try to see if we get the same outputs or not. Okay, now I am going to define two-dimensional tensors, and I'm using TF-add or matrix multiplication operations on both to see what we get as the results. Alright, let's go ahead with multi-dimensional tensors. So with TF1s, we define a tensor that has the shape of 2 and 3 and 6. This is not a vector. This is the shape of a TF1s vector, as you can see down here. So let me just show you TF1s to make sure what that is and show you. Okay, you see we get a shape. We don't get a tensor, we get a variable. So we get a shape, and it creates a tensor with all ones with the shapes that we define. For example, with this TensorFlow example is 3 and 4. And the data type can be specified by ourselves. So I just put TFFlow 32 here. Let's just go ahead. Here there are sort of different operations. We can take the rank of the tensor. With tensor.shape, we get the shape, tensor dtype, data type, tensor.shape1. It says, okay, what is the size of the second axis of that tensor? Tensor.shape -1, the size of the last axis. So if the shape is 2, 3, 6, as you can see, the size of the second axis is 3. This is particularly useful when working with features. Sometimes we want to get the shape of tensors. Not specifically all the shape matters to us, but we want to get the shape of specific axes as integers to do further operations. So here's the size of the tensor, which is actually the number of all elements in a tensor, and in general the number of dimension is 3, and is in this example is actually equivalent to the tensor rank. Okay, we run it here. We define another TensorFlow constant, and with this we actually get all the variables, all the elements, sorry, and with numpy we return it as numpy. Then we get sort of the first row and all the columns, and it's going to be x0 and minus 1 is the first one, the last column, and so on and so forth. This is a sort of indexing that we can do with TF tensors by TensorFlow that can be done exactly with numpy as well. So this is actually x is a TF tensor, and all those indexing that we can do with numpy, at the very least most of them we can do with TensorFlow as well. In the last part, I'm going to show you actually the data types that we have here. We can cast the data types and actually change the data types with tf.cast. For example, here the original tensor type is int32, and the original tensor d type is going to be returned by tensor original tensor.dtype. Now we cast the original tensor to type TFFlow32, and we want to see the final output. So you do see we have here the type of int32, but here the tensor type values type change from int32 to float32. This is particularly useful because in a lot of machine learning operation we are limited to work with a sort of tensor type in our operations defined by different TensorFlow layers, optimization, etc. And here was a sort of general overview of the tensors and tensors operation and how we work with them, how we get the shapes. I hope you find it useful. In the majority of experiments, you don't need much more than what I just provided here. Hopefully you enjoyed it. Feel free to fill comments if you had any questions or point of view. I really appreciate it. All right. Thank you so much for your attention. See you soon.